Hello everyone, welcome back to my channel. Today's topic is the differences between the core type and the shell type transformers. Here comes the 8 most important differences between a core type and a shell type transformers. Let me explain each and every point in detail. The first one is a core type transformer has two yokes, two limbs and one window. First let me tell you what an yoke is. This one is nothing but the core. So the horizontal core is nothing but the yoke, and the vertical core is nothing but the limb, and this is nothing but the window. So now we can say that this is yoke and this vertical one is limb, and this part in the middle is nothing but the window. So a transformer has two yokes, that is two horizontal cores, two vertical cores, that is two limbs and one window. A shell type transformer has two yokes, three vertical cores, that is three limbs and two windows, one window and then the window. So this one is the first and the major difference. And the second one is windings around the core. So here this one is the core and this one is the winding. So windings are surrounding the core, but here the core is surrounding the winding. Windings are here, but here there is core. This one is core, this one is winding, and this one is core. So the core is surrounding the winding here. So this is in the shell type transformer. So here in the core type transformer, both limbs are provided with the winding. So both the limbs has the windings here. Okay, but here only, as there are three limbs, 1 2 3, only the central limb will be provided with the winding. The another two limbs are just cores left, they have no windings present around them. And next comes the important point, the concentric windings. All of us will think that core type transformer looks like this and the shell type transformer looks like this, but actually a core type transformer looks like this. That is, in a core type transformer, we'll think that LV or HV may be present here. Here I showed HV here and LV here. So H will be present on one side, LV will be present on one side. No, it does not happen in the actual case. Actually what happens is the LV winding will be first worn around the core, and over that will be winding the HV winding. First LV winding will be wound around the core, and then will be winding the HV winding. Why do we do that? It is because of some insulations, because of insulation. Actually if we wind directly LV to the core, will be having less insulation requirement. The reason will be there is one reason. That reason can be explained later. So first we'll be concentrating on this. So if we wind LV directly to the core, the insulation requirement will be less, and over LV winding, if we wound the HV winding, then the insulation required between LV and HV winding will be less. So we'll be using like this. That is, there will be a core, on that core will be winding LV, over that LV winding will be winding HV. Similarly, on the another limb also same process takes place. So actually a core type transformers will be having both LV and HV winding on both the limbs, other than either HV or LV on one limb, on both the limbs. Okay, so this one is a major difference. So what are we doing here? First, over the core we are winding LV, over that we are winding HV. So the windings will be concentric. The center of these two windings will be same. But in the case of shell type transformer, we won't wind HV over LV. They both are wound on the same limb, but not overlapping, not over one over the another one. They look like an sandwich. So these are called as interleaved or sandwiched windings. This one is concentrated type. They have the same center. Here they are wound in such a way that they look like sandwich, one below the another, like that. Okay. And also as HV winding is wound over LV winding, so this one is core, over that we are winding LV, and on that we are winding HV. So HV winding will require more number of turns, more number of wire, because over LV we are winding, so it requires more number of more length. so the copper requirement of the wire will be more. But here we are directly winding HV winding over the limb or over the core. Means we are directly winding on the core, not winding on LV winding, so the requirement of the wire will be less compared to the core type transformer. So here the copper required will be more, here the copper required will be less. Copper is nothing but, as the wire is made up of copper, we will be saying that copper requirement, that is wire requirement, will be more here for HV. Here the copper or the wire requirement will be less. And the next one is no mechanical protection to the windings for the core type, because the windings are directly surrounded over the core. But here core is there and winding and then core, so the windings will be having protection by the core on both the sides. Here there will be no protection of windings from the core, so there will be no mechanical protection to the windings. Here good mechanical protection. Okay, and next point is, if we open the transformer directly, we can see the windings as they are present outside, so we can find what is the problem, if there is a problem in insulation or if there is problem in wiring, so we can easily check and we can easily maintain and repair it. But here if we open the transformer, there will be core, winding and again core, both the sides it will be surrounding by core, so it is a very little bit difficult for us to check, to inspect where the problem is, and to maintain and to repair. It is a little bit of difficult for us, it is a little bit of difficulty for us. Okay, and next this core type transformer is suitable for high voltage and extra high voltage installations, and this shell type transformer is more suitable for low voltage installations or very high required current installations. So these are the basic differences between the core type and shell type transformers. Thank you for watching. Please to subscribe.